All right, Civil 330s. I wanted to make a quick video. Well, maybe it's not going to be so quick, but a video on our latest assignment in which I'm asking you to look at a beam that has some pin connected members attached to it. So it's sort of kind of a hybrid type of structure. I think the previous videos I've done, we've just looked at how to model trusses using SAP 2000, and I wanted to talk about some of the differences with modeling something that looks like this. For the purposes of this, going over this, I'm going to keep the same dimensions. So the beam spans here and this depth here of 1 meter. I'm going to keep the same material properties and the dimensions like that. As far as the loading on it, eventually the way you're going to work it down, you're going to have some sort of a uniformly distributed load on that. You're going to have a certain value based on the calculations and the loadings that I give you at the start. But for this video, I'm just going to assume I have some loading here of 10, let's call it kilonewtons per meter. And my squiggly lines here maybe don't make this clear, but let's just assume it's all pushing downward like that. Okay, so pretty standard. So I'm going to talk about how to model it with that loading, no self-weight. Okay, I'm going to turn that off, which is what you're going to want to do in your assignment, by the way, just to make it consistent with your hand calculations. So SAP will easily include the self-weight of all the different components, including like these steel rods here. But that's going to mess up your comparison to your hand calculations, where that would get way trickier to do with the force method. Okay, so let me go to SAP. I'll pull that up, and if you look in the lower corner here in SAP, I've switched to units of kilonewtons and meters, but you can use whatever units you want. And what I'm going to do is create a new model. So click on new model, and then I have the usual grids. So remember, our basic screen, the default is we have the X and Z plane. So in the X direction, so that's going to be along the length of the beam, I'm going to make that I'm going to use 2 grid spaces and have them spaced at 3 meters. And then in the Y direction, I'm actually just going to have, let's do 1 space, and we'll keep the default here of 1 meter. And so that will allow me then to like model the depth of this truss, this 1 meter depth here. And then the Y doesn't matter, but I like just making it 1, just to keep it simple. So I'll do OK, and then I get something that looks like that. I'm going to close that one, just because I like doing that. And then I'm going to go to my XZ plane. Okay, so here is my basic setup. Okay, how do I want to model this thing? So if we look at this setup, I've got, this is a continuous beam, okay? So don't get fooled by the connection there. That connection is not going right down the middle of that beam and completely splitting it open. What you can imagine that as is maybe we like drill a hole into the wood beam and then attach, like, I don't know, some sort of a pin, and then we can hang off this steel member off of that. So this beam is continuous, but we have these attached to it, these 3 pin connected members. So how are we going to model that? Let me just kind of show how I'm going to initially set this up. So I go over to that frame element thing, and I got my pointer here. I'm going to click here. I'm going to click there. I'm going to click there. There. And there, and then I'm going to press escape, and I'll do the final element here. I'm going to go here to here, and then escape. Okay, I have kind of, let's see, 1, 2, 3, 4, 5 different frame elements laid out there. I'm going to now add in some supports. So I'm going to click here, and I'm going to go up to assign. Let me get this little screen out of the way for a second. Oops, didn't want that. I'm going to do assign joint restraints, and I'm going to pick the little pin thing. And so it gives me a pin there. I'm going to go over to this one on the far side. I'm going to click assign joint restraints, a little roller thingamajig like that. And now I got my roller over there. Okay, now what I want to do is also tell SAP that this member, these two diagonals and that vertical member are basically truss members. They're pin jointed. So what I'll do is I'll click each one of those, clicky, clicky, clicky. And what I'm going to do is then assign frame releases for just those. And it's the old trick that we did with trusses. What we're going to do is we're going to release the moments. So the torsion, it doesn't really matter, but we'll do that. Notice you can only click either the start or the end. At each end, though, what we want to click is we'll click, the key one is the moment 3-3, but just do both of them and do it at each end. And then I click OK, and then the little green dots show up, which just remind us then that these SAP is now considering those 3 members to be pin-ended members, which is exactly what we want. Now, notice the beam does not have any green dotties on it, okay? It just has the one yellow dot right there in the middle. From the point of view of SAP, okay, this is like having the 2 ends of those members like welded together. So it treats that as continuous, okay? What it's viewing this as now with that green dot is that, you know, that pin is now attached to the bottom or, you know, the center of that beam. But that pin is not delving into the cross section of the beam itself, creating you know, another pin connection in the beam. If we did that, in fact, that would essentially be turning this into an overall truss. Everything would be pin connected, which is not what we want. We want that horizontal beam to be continuous and these 3 other members to be pin jointed members. Okay, I'm going to stop there because the video is getting a little bit longer, and then I'll come back. I'll talk about how to assign the material properties as well as to apply the loading to this truss. So see you then.